I left off the C for you, Laura. I left off the C for you. You're welcome.
-4 for 1.
That's right. Just maybe like an inch of tree.
Everything is 0, right?
So limit t approaches 0 from the right of that antiderivative.
Okay. I jump all that stuff. It's hard. I see a lot of things. What the
Yes.
What do you mean? Oh, yes, we did.
If it's at the end point, you don't have to worry about it. But if it's inside, then you do.
We did it right, so
You got that so far?
we got the answer already.
Did it converge or diverge?
Converge.
It converged? I think it does converge. I just want to make sure. Does anyone need help with this? What? Yeah? No?
We get the 1 over x.
This right here?
Yes.
Put these two together. That's root x over x, right? Which is the same as x to the half over x to the 1. And then when you subtract a half minus 1 is negative 1/2, but then I dropped it back down and made this. Is that good? Another way you could see that, root x over x is the same as root x over root x times root x. That's x. One of them cancels. One of them cancel.
We just did everything to the 1/2 of the root x.
And that's okay. All right, so assuming you can get this part, right? Assuming you can get this, then you rewrite this integral as a limit. You're going to approach 0 from the left, and you replace the lower limit of integration with t. And now you're going to plug in. You're going to have your limit as t approaches 0 from the right, bracket, parenthesis, parenthesis. And first we plug in 1. I think 1's going to be pretty clean. 1 goes in here. 1, natural log of 1, 0. So that's going to be a 0 right here. Well, I'm not going to write there. 0 minus, then 1 here, so minus 4. So that's what you get when you plug in 1. And then when we plug in t, we get 2 root t natural log t minus 4 root t. This is the part that requires a little bit of work. Because if you let t go to 0, right? If t goes to 0, let's take care of the easy part first. This piece goes to 0, right? The 2, just ignore it for now. This piece right here goes to 0. And this piece, natural log of 0, we already went through that earlier today. That's negative infinity. So this right here is what's happening with those two pieces. And because of that, you can't just tell me that that's 0. You actually have to go through the work now and prove to me that that's whatever you think it is. So everyone understand that what's in red circled there I've got to work on now? Okay, so I'm going to do that so that I can keep this on the board. I'm going to do that over here. I want to know what the limit as t approaches 0 from the right is of just root t natural log t. I get 0 times negative infinity when I do that. That's an indeterminate form. Did y'all get that email I sent? I sent an email out, I believe, that gave like links to videos from or told you like where to go if you wanted to see L'Hopital. Okay. So I got this. Whenever we see that, what's the technique we do? Drop one of them down. You have to drop one of them down. I'm going to leave the natural log here. I'm going to drop this one down. So this becomes limit. T approaches 0 from the right. Natural log t is on top. And on the bottom, I'm going to write that. I can do it as 1 over root t. And now the reason why we do this is because when we rewrite it this way, this right here, we already know goes to negative infinity, right? This one right here is fixed over 0. And it's always positive because the root's going to be positive. So we have positive over positive. that goes to infinity. So you have infinity over infinity, and then that's the point you can use L'Hopital. So I'm going to bring in L'Hopital now. Sorry, I've got to erase this. What?
I get that natural log of 0 is negative infinity.
Is headed towards negative infinity.
And then, oh, fix everything. Okay.
Yeah, this is fixed over 0, not fixed over infinity. So now L'Hopital. So by L'Hopital's rule, I take the limit as t goes to 0 from the right. I take the derivative of the top, which is 1 over t. I take the derivative of the bottom, which, you know how to do that? This right here, that's t to the negative half, right? That's what that is. Take the derivative, negative 1/2 comes out. T to the negative 3/2. Derivative, not integral, right? But that's equal to, gosh, limit t goes to 0 from the right. How about this? 1 over t over negative 1 over 2t to the 3/2. So I'm just dropping that down with the 2, and then I'm going to flip and multiply. So that's limit t goes to 0 from the right of 1 over t times 2t to the 3/2 over negative 1. There's so many different ways you could clean this up algebraically. This is just the way I chose to do it, all right? And then what happens with these t's right here? What does that become? T to the 3/2 over t is t to the 1/2, right? So at the end of the day here, I get limit t goes to 0 from the right. I have a 2, I have a negative 1. So negative 2, then I have a t to the 1/2, which is root t. And that limit goes to 0. So this goes to 0. So again, on the exam, if you run into this, I need to see this, okay? You can't just say that that goes to 0 with no evidence supporting it.
So there's probably not going to be that many questions.
Yeah, we're done, so we can talk about the test. What's the answer to this? This was 0, boom, and then all we get is the negative 4. So minus 4, negative 4 converges. Converges to negative 4. All right, so the exam. I have not written the exam. But my guess, 6 to 8 questions. 6 to 8 questions seems reasonable for the exam. Yeah.
But isn't there like 3 chapters we did?
It's a lot. Well, I mean, what does it cover? It covers trig substitution, trig integrals, right? But think about it. If I give you a trig integral problem, you're going to have to do, if I give you a trig substitution problem, all those problems with the triangles turn into trig integrals with either sines, cosines, tangents, and secants. So I can give you one trig integral problem that would knock out those 2 topics, right? There's partial fractions. There's improper integrals. And then anything else, right? Like integration by parts. This problem right here had integration by parts in it, right?
Yeah.
So 6 to 8 questions. You need to know how to complete the square. Remember there were some problems when we did partial fractions where you had to complete the square? You know, when do you do that? When do you complete the square? When you have irreducible quadratic underneath a
X plus 1 or something, 2 different.
linear or a constant.
What is that? Irreducible?
If your denominator is an irreducible quadratic and your numerator is a constant, you'll complete the square.
Or a linear.
What happens if you have a linear over an irreducible quadratic?
Depends.
you force the numerator to look like the derivative of the denominator. That's where we came in with like that 8/8 and like massage it and hidden zeros and stuff like that. You need to know how to do that. That wasn't just for fun, okay? And complete the square, massage the thing to make it look like what you need it to look like. Of course, long division, you'll have to do long division. You're going to have to solve a system of equations, but I don't anticipate that you'll absolutely need RREF, but be prepared for it. I think what I'm going to do is keep it pretty straightforward. I did give you that one take-home quiz. Remember, that was an RREF. I don't anticipate anything like that, but be prepared for something like that. You never know. I may be all upset when I'm writing the test. Take it out on you. No, I'm kidding. What else? Okay, so look, I mean, like, how are we going to address definite integrals? Definite integrals, not improper, definite. Well, any of the problems that I give you that require partial fractions or trig sub or something like that, I just throw numbers on them and just have you evaluate it at the end, right? That's the only difference if I put numbers, is at the end you have to evaluate. So I would anticipate seeing numbers, definite integrals on these things. And I gave you a homework assignment that was to go back and look at old homework and work them out. So it's like the same concept. Improper integrals. There was one here where we did partial fractions, right? So if I wanted to knock out a certain type of partial fraction problem, I could do that in a improper integral. Now, I don't have like a formal review for you, okay? So, but I was looking at the chapter review, just looking for additional problems. And please do not take this as, oh, he gave us like exactly what we need to study, okay? Because you need to study everything. I was on page 363, and I just circled number 6, number 11, number 18, number 49. 6, 11, 18, 49. Those just looked interesting to me. 6, 11, 18, 49. On 363. 6, 11, 18, 49. So if nobody has their book, but like 6 looks like a definite integral, so it has numbers, and it's an integration by parts problem. Number 11 is a definite integral, but it looks like a trig sub. Number 18 is not a definite integral, but it's partial fraction decomposition without long division. Number 49 is an improper integral from negative infinity to infinity with an irreducible quadratic in the denominator, which means you've got to do some work. You've got to do some completing of the square, and then at the end run some limits. So, all right, I think one of the biggest issues for this test will be time. All right, you have 100 minutes. If I give you 8 questions, that's still only about 10 to 15 minutes a problem, right? I mean, and I just gave you one, right? And I stepped out for 15 minutes, you know, right? And I came back. I know it was the first time you'd seen it, but, you know. So time is going to be an issue. So what can you bring? You can have your formula sheets. You can have, can I borrow?
Yeah.
You can have this sheet that has the trig integrals and substitutions. You may have that.
Instead of the bonus points, we just do a group exam.
Group exam. Make sure you eat before you come to class. Make sure that you sleep the night before. And come in confident. Because after it's over, spring break.
It's either we're going to drink.
All right, that's all I've got for you. Oh, the homework for this section. I gave the homework assignment last time, but just FYI, I asked you to, you should do up through 21. Now you can do the rest if you're wanting more practice on what we did today. All right, y'all have a great rest of your day, next 48 hours.